Hi. I wanted to do this video as a follow-up to yesterday's video about my semester project for my operating systems class. And I wanted to go over more specifically bit masking. I do realize that probably if you're watching this video, you're very much familiar with it, but there are people who are not, and I would like to make sure that I do explain that concept at least a little bit, just in case somebody who clicks on this video and is not familiar with the concept. So we'll go ahead and launch our terminal. And SSH into my Linux machine. And launch a nice console terminal. And navigate to okay, let's try this again. Okay. And we navigate to the ETSS software, and we'll go ahead and launch it. And then run the server. Okay. And let's just do one run so we can illustrate what we're talking about. Okay, here we go. This is what I'm talking about. 7 means 3 tests. And the IP address, obviously, 168.1.5. And as you can see, there's test 2, test 3, and test 1. All 3 tests are running, just like they were yesterday. And we can go ahead and just stop this, because that's not what we want to see today. We don't really care about that. What we care about is, why does this 7 mean 3 tests? Well, easiest way to illustrate that is with a calculator here. 3 ones mean 7. And let's go and look at the code, why that's the case. And here we go. Okay, so what's happening here? The ETS takes in a run mask, an unsigned integer, which is 32 bits, and it takes in a stop mask. We're not going to worry about the stop mask. That's whether we want to continue running the test even if there's a failure or not. What we're interested is in the run mask. And the run mask gets passed in to the get bit function. So this just gets 1 bit out of a 32-bit variable. And what we are interested in is the beginning positions of that 32-bit variable. So for example, well, let's put this in hex so we can there we go. That's a 32-bit variable in as you can see here in hex, and that's the representation in hexadecimal. That's the representation in decimal. And what we were interested is in this last part right here. So if we change that last part to a 7, you'll see 3 ones. And in our case, we don't care about any of the other bits in this 32-bit variable. We only care about the first 8 bits to be exact. But really, since it's only 3 tests, these first 3 binary digits, which is the 7. And if we delete that and make it into a 5, now you see my illustration as if it's test 1 and test 3, but not test 2, you would have a 5. And obviously, if we delete that and make it a 1, then we just see test number 1. So how do we accomplish that? Because we need to look inside that variable. Well, that's why I have this function. This function does that for me. Well, how does it do that? We go in and navigate to that function, and we'll see that what we're actually doing is we're doing a shift operation and then an AND. So we're shifting by the number of bits that we want. So we're shifting this 1. So we have the variable 1 because we're going to AND it with what we want. So let's say we're only wanting to run test number 1. So that means we're in position 0, the very first position. We don't shift by anything, and we AND it with the mask, and the mask is a 1. Therefore, the only part that's true is the very first element. But what if we had the situation that we had in the demo 7? Well, then the loop goes through all 3 positions: position 0, position 1, and position 2. And first we don't shift at all, then we shift by 1, then we shift by 2, and we AND against the mask, and the mask is 7. So 3 ones. So that means each time that we AND and we shift, we hit a 1 and a 1. So 1 and 1 equals to 1. 1 and 0 equals to 0. So all the other ones equal to 0. Therefore, the software doesn't launch those tests or those unexisting tests. So going back to the caller, as you can see, this if statement only executes if this function returns true. And it will only return true if the mask and where I'm shifting into that mask is true. And then it does the launch over here, where you can see where I'm actually launching the well, I'm not launching the threads quite from there, because what I actually do, the way it's launched, is through function pointers. And I will show that. And each function pointer is inside an array. And this way, all the tests get launched the exact same way. So this would be test 1, test 2, test 3. So position 0, 1, and 2. But wait, how do we figure out why, since we're counting them by test ID 1, 2, and 3, just like we are over here. See, 1, 2, and 3. This is not 0, 2, and 3. Because we humans like to count from 1, not from 0. So how do I accomplish that? Well, I just simply correct that here. I take the index, which is 0 for test number 0, and I add a 1 to it. And I store it into the test ID. And that's it. I do that for each pass of the loop. And that concludes this demonstration and this lesson about bit masking. If you like boring content like this, please subscribe and like the video. Otherwise, go to Enigma Climbing.